Let's talk about kernel stack. So here is process A, and let's consider that we have a 4 GB of RAM. So the first address will be 0x00 and the last address will be 2 power 32 minus 1. This virtual address space is divided into two parts. The first one is kernel space and the second one is user space. Now the user space will be further divided into various regions, like it will store its own stack, its own data segment, its own text segment in this user space. Okay, and then there is this kernel space, which again will be having some other regions. Now, let's consider the RAM. This is the RAM. So it has various processes, process A, process B, and also it has this region occupied by kernel, which again is divided into various regions. First region stores the kernel code and data, the second region stores the process management related data, and so on. We are interested in this process management data. This particular data is again further divided into various regions. So basically, it stores data for various processes as well. So let's say this is the block for process A. In that block, it stores PCB of A and kernel stack for A. Now this part is mapped to the stack of the process A from kernel space. So this is how the mapping is done. And also this data uh, from process A from kernel stack is mapped to the data segment from the RAM, from the region occupied by kernel. This has to be some address, this has to be some address. Okay. The addresses of the kernel text or data segment can be same or different, but they will be point to the same address or page in the RAM. We'll see in the next video that how the kernel space is utilized during the context switch.